In the following exercise, use direct substitution to show that each limit leads to the indeterminate form 0 over 0, then evaluate the limit. All right, so in this situation, we have a limit, and the first thing we should always do with a limit is plug in the limit value. Just see what it comes out to. So 1 plus 0 squared is just 1, minus 1 over 0. So this is going to result in the indeterminate form 0 over 0. And that generally means there is some algebra that we can do in order to evaluate the limit. But even if that algebra exists, and even if you know what that algebra is, it also means that you can apply L'Hopital's rule and then use that to solve the limit. So the derivative of the numerator, we'd have to use the chain rule here. Bring the 2 out front, leave the 1 plus h alone, subtract 1 from the exponent. The derivative of a constant is 0, and the derivative of h in this case would just be 1. Now if I plug in 0, I would have 2 times 1 plus 0, so this limit is equal to 2. And absolutely, we could have done some algebra to figure that out as well, but that's not necessarily something that we have to do. We could have expanded this polynomial and the ones would cancel. There's a factor of h here which cancels one of these and one of those. So I now have the limit as h goes to 0 of 2 plus h, which when I let h go to 0 results in 2. But L'Hopital's rule gives us an alternate method of solving when we run into the 0 over 0 or infinity over infinity type.